Good afternoon, everyone. Thank you so much for coming back to join us. We're proud to present our next speaker, Andy Walton with Densify. Please give him a warm welcome.
Thanks, Trish. How are you guys today? My name is Andy from Densify. I'm the VP of Technical Architects for the Densify team. If you've been hanging around the trade show floor, you'll know us as the lightsaber guys. So right up the way after the presentation, you got Q&A. Come by, get a lightsaber, and we'll chat. Today I'm going to talk to you about getting better application performance and as a result, lowering your cloud spend with optimization as code. And we'll start this journey with this guy I call Mario. So Mario's a cloud operations guy, and he's stuck in the middle between two very important and powerful groups. One is the application owners. So these are the folks that say, I need exactly what I asked for from an application instance perspective. Don't you dare downsize it. I want to make sure that application performs. And on the other side, stuck in the middle between the IT finance folks, who are the ones that are saying, we're spending a ton in the cloud, and I want you to see if you can lower my cloud bill by 20 to 30% every month. So it's a very difficult place to be. And so we're going to talk about how we help his life out. So the first thing is we talked through Mario. There's two things he has to do, really, in order to balance these two groups. One is understand the application demand curves. So he's got all kinds of different raw utilization data, tons of vendors out here that will provide him information on exactly what those instances, the auto-scale groups and RDS are doing on a day-to-day basis. So a lot of raw utilization data. On the other side, he's got all these different AWS offerings, all these different service offerings. In fact, last count, I think there was, well, actually after the announcements today, it's probably more than 2 million combinations of things they can buy up in the AWS cloud. So the considerations he's got in order to keep these two groups happy is, should I commit to the RIs? Which instance family? Cost tactics? Which region to buy in? Which storage options? Which instance generations? And of course, as he's doing this, it's not a one-time job, obviously. The evolving app resource demands every day these resources are changing in terms of what it is that they're doing on a day-to-day basis. And as we said, these offerings are changing the supply that's available from the cloud provider. So how do we actually get to optimize the cloud? That's interesting. So first thing is understanding the raw utilization data and the numerous service offerings. Between those two things, the first thing you have to do, and again, this is, a lot of companies have approached this using smart guys with spreadsheets or some of the cloud bill readers. We'll talk about those things in just a moment. But first thing you have to do is establish a predictive demand pattern using advanced machine learning. And the idea being is that we want to understand what those workloads have done over time, say the past 30, 60, 90 days for certain classes of workloads, and predict what they're going to do in the future. And the second thing that's very important is to create a normalized model of the cloud supply. So not just in AWS, but a lot of companies have a big on-prem infrastructure and they're moving into the cloud. So we've got to normalize that relative compute. You may be having workloads in GCP or Azure that you're moving over to AWS or bare metal in the cloud. So that normalized model is very important as you're determining, will that workload work with that supply? And of course, that whole analytics of being able to optimize the demand and the supply using deep permutation analysis. This is not just, say, a simple, what's happened on average or a peak, say, over the last 30 days. It's a heck of a lot more complicated to get the right answer out of it. A lot of companies address this, as the finance people were talking about, well, lowering my cloud spend. The first way they went out there to really deal with it was by a bill reader. And so as the resource usage and the costs went up, understanding and reading that bill on a monthly basis, generating financial reports, in some cases lowering that monthly cloud spend by recommending RIs. And that's certainly a strategy you can go about doing, and you will lower your costs doing that. The problem is it doesn't address the problem at its root, which is matching the application demand with the supply in the first place. One unreadable example is on the screen here. And the idea being is that you'll see as you analyze and look through the different options that you have, in a lot of cases what we find is that companies are buying the wrong stuff right off the bat. And it's not just the wrong stuff in the instance family they're in, but they're buying it in the wrong family. You might have a compute optimized workload or something that's focused heavily on compute. You got general purpose or IO focus. So The idea being, as we analyze these workload curves and make recommendations for what they should be running on, again, the underutilized resources will come out in terms of the predicted model and saying, you've provisioned way too many resources in the effort of trying to mitigate risk. And so what we'll see on and over again is that as we analyze these systems, that are 5–10% used in a lot of cases. Now, imagine if your application's just new. So there's a number of considerations here, and again, I've got an issue with one of my builds here, but number one, I'm compute intensive. So understanding if the application says, yeah, I'm compute intensive, I have a peaky workload, I'm busy most mornings, and I also have some business considerations as well, which is I'm part of an active passive pair, I have to be provisioned on the East Coast, and you can add in all your different considerations that you might have yourself, such as I've got customer data, and there's certain places I can run and certain places I cannot. So it's understanding that workload and then saying, all right, the analytics tell us that the newly released, or at least in this case, not so newly released, C5D 9 extra large is the optimal instance to run this particular workload. And you'll notice nothing about that recommendation is based on cost. And that's what we find with the application owners. They don't care about taking a recommendation based on the fact it's going to save them 20%. In fact, they don't care what resources you give them at all, they just care that you give them enough. And so in this case, it's really all around matching that demand with the supply. Once you do that, what you'll have is better performance of the application itself, better utilization of the actual instance that you've picked, and an overall lower cost. So starting with something like compute and your database, your RDS services, analyzing and optimizing those will generate a drop in terms of the resource cost over time. Instance family optimization, so now looking at which instance is that family running in today, and could it be better served by running in, say, an I/O optimized or a memory optimized instance. Scale group optimization is not just around optimizing the size of it, that's part of it, but also understanding the minimum and maximum nodes from a predictive perspective over time, and whether or not you should have more or less. And again, that will help optimize how that application performs, making sure that you have the correct number of nodes running in that scale group. Container optimization is obviously a big discussion. We've had a lot of talks with folks here this week around things like Kubernetes and ECS, and now doing the exact same thing, not just on the instances themselves, but what are the containers doing, and are there ways to actually intelligent stack those things inside of EC2 instances in order to optimize the usage of those things. And finally, by making sure that you're buying the right stuff in the first place, you can establish a very much more intelligent buying plan in terms of your reserved instances and optimizing those. So what you'll see over time is that cost curve really will drop based on understanding what those workloads need, what the supply actually matches with those things, and then driving an ROI purchase strategy to actually drive that cost to the lowest possible area over time. So I talked a little bit about optimization as code. So this is all great, and now CloudOps is now convinced that we actually have built a better mousetrap in a lot of cases, but this is one of the sources of the issues that we see today. How do we automate all these things? So here's an example of a DevOps guy, and I don't know what his name is, let's call him Joe. And Joe has been working as a code their infrastructure requirements inside, say, a Terraform template. It could be CloudForms or CloudFormation. But what we find is companies are actually doing this. They are committing to these micro purchases, which in many cases are based on tribal knowledge. They're based on sizing instances like they've sized them all the time. And so what we get is a heck of a lot more resource request than usage over time. And so hard coding it is the first start of the issue, and we'll show you how we solve that issue. The first part is understanding and creating self-aware applications. So even if we don't even get into the automation part of this, what you'll see is how do we make these applications self-aware of their requirements? And so what you'll see here is a bunch of instances running in AWS, and I can barely see that from the screen, so I'm going to look at it from over here. And so what we're highlighting here is one specific workload that's running in an M4 large, and by taking the analytics and now tagging them using AWS tags, we can make those applications self-aware of their actual requirements. So as we analyze things and say things like, all right, now I'm just going to tag those instances and say, well, you're running on an M4 large, you should be running on, say, a T2 medium or a T3 large. What's your potential monthly savings? What's the uptime? Should it be running on a reserved instance? Should it be running on an on-demand instance? So the analysis findings of the machine learning and the predictive analytics and the optimization actions actually get embedded inside that instance as it's running to make them self-aware, to make cloud ops aware of what exactly that resource requires. That's the first level of integration. So if we go back to Joe here, so instead of actually hard coding this inside of his Terraform template, we talk about calling a single line of code. And now going into the analytics engine, it's like, instead of me hard coding this, you tell me what I need over time. And the beauty of doing this is that not only on a one-time basis, but on a continual basis now, it will continue to analyze and optimize that instance, saying, well, its workload patterns may change over time. The supply may change again. So by doing this, you now have a perfectly balanced application forever, essentially, because it's going to constantly update and analyze as opposed to just using what we've always used as a hard-coded infrastructure requirement. So the cloud instance will become self-optimizing based on its learned behavior, and we call this continuous optimization, and it follows along with a paradigm of continuous integration, continuous delivery, continuous deployment. So we call this CI/CD CO for continuous optimization. It works exactly the same way for containers. So as you specify the amount of CPU and memory and the limits for those things, and again, poor Joe is looking rather pensive there, saying, what should I actually size this thing for? I'm not sure. I'm just going to give it a ton of resources. So the exact same process follows here, where we can do a lookup for those containers over time, and the container optimizes itself, and he's very happy. The idea being is that as we analyze and do this in a container-based world, we can stack more workloads inside of an EC2 instance, and now the scheduler will get more efficient in terms of as it starts parceling out these specific container nodes onto individual instances. It will be better. It will actually have potentially, in a lot of cases, 30 to 40% savings on the CPU and memory, and it will become more efficient as it stacks those things together on the EC2 instances. Now, the key to success in all of this, Cloud Ops is convinced, but the finance people, but the DevOps folks in particular, and the application owners need the evidence. You can't just make a recommendation based on cost. I'm going to save you 20%. Again, I don't care. So the key that we found is engaging the application owners and providing them the detailed scientific and the cost-based evidence is exactly what they have beforehand. So that's what your instance looked like before, Mr. Application Owner. When we move it onto this new optimized instance, it's going to be a little bit busier. It's going to have better utilization usage of that instance it's running on, but it's going to be perfectly fine in terms of the performance and the speed that you're expecting. And so here's all the differences. Here's all the core technical and business detail on what those differences are. And again, we see that as being key to engaging these folks and in getting their buy-in, because you're not going to change these instances without these folks saying it's going to be okay. Part of this process as well is potentially taking this, and from a semi-automated perspective, we're seeing is taking this kind of evidence and building it into something like a ServiceNow or a Jira ticket. So as we see these recommendations come along, being able to actually integrate into that ticketing process to say there's an approval that has to happen. They have to see the evidence and click on it and say, yeah, I'm going to do this during the change window at 2 o'clock in the morning on Tuesday. So that whole integration process is very important, and you see that for enterprises, because it's not like you can just say, well, just change it right now. We're in the middle of the day. We can't just start taking these recommendations without certain folks saying that it's all right. At the end of it, everyone will benefit. So your application owner says, I've got the resources that I need, and my users are happy, and I'm not getting paged at 2 o'clock in the morning. The cloud operations folks are happy because they now have automated optimization or semi-automated. It all depends on their appetite for optimization and automation in that company. And of course, the finance folks are saying that everyone's happy and my bill is lower, so that makes me happy as well. An example of what this can drive in a specific customer example. So here's a digital service provider spending $20 million a year in AWS, having difficulty matching their apps with the optimal instance sizes, and their RIs essentially, yet they were saving money buying RIs, but they were buying the wrong stuff, because 84% of the instances that were running in their environment were sized incorrectly. They were running on the wrong instance sizes. And as of using a bill reader, again, they were buying RIs, they were saving some money, but on top of what they were doing on the bill reader, the opportunity to save over $600,000 a month simply by lining these things up properly and driving a more intelligent RI purchase strategy. So the results can be very, very compelling. So just a quick commercial in terms of how we get there. This is from Densify. We call ourselves Next Generation Cloud Optimization for Cloud Ops, designed for Cloud Ops. And again, the whole idea is making these applications for self-aware and then self-optimize by continuously matching their demands, their requirements with the right cloud supply, which really leads to better performance, less cloud spend, and it's automated. And you notice we do this picture for a reason because we run this as a service. So it's infrastructure or software as a service, but we run it for our customers, which means that they don't have to install anything, they don't have to implement anything, they don't even have to learn the software or read a manual, we'll do it for them. We do have certain data scientists in our population that say, I want to learn this stuff because I want to do it myself, which is fine. But if they don't want to, they got 19 tools already and they don't want to learn number 20, we see a lot of our customers do the uptake saying, that's great because I really just want to consume the outcomes. I don't want to have to learn how this thing works. The engine is, we call it Chloe, the Cloud Learning Optimization Engine. Chloe takes in the kind of information I was talking about earlier, the application demand patterns from something like AWS that will come from CloudWatch. We would augment that with pulling in data from something like a Splunk or a Datadog or a SignalFX. So if you got memory data up there or other metrics, we pull that in. The more data you have, the better you're going to be able to predict what a workload is going to require in the future. We add into that the business and functional tags that come in, so being able to separate by line of business, or say that's an active passive pair, or that's got customer data on it. So all that tagging information goes into the right-sized decision on the cloud supply, and that goes into the policy engine as well, which is all the different thresholds and limits that say, well, when do I need more resources? When can I safely downsize? It's different for production versus test dev. And so from the cloud supply side, we pull in the details on the cloud services models, the performance and the benchmark information, automatically resolving just how powerful those instances are. We've already updated our analytics this week based on the announcements from this morning, and that's the other benefit of running this as a service. You don't have to do it, it happens automatically. And then any technical rules that come in terms of, hey, there's a new hypervisor out there, or there's a different storage type, all the different rules that might say, well, I can't safely go from an M4 to a C5 because of this. The analytics will pick those things up as part of its recommendation engine and make sure that it's not recommending something that's going to be against the laws of nature or taking you back 2 or 3 different instance generations to the wrong generation. And driving out of that, you have optimized cloud, analyzing something like a VMware environment, full predictive analysis in terms of as you move from the on-prem into the public cloud, what exactly should you be buying so you're not, again, overbuying as part of that migration analysis. Workload densification, and that works for both on-prem, so as you analyze your VMware environment, if that's still part of what you're doing, then workload densification is like playing Tetris with workloads. And we do that if you're running VMware in bare metal. And you also do that for systems like, obviously, containers. So being able to stack individual containers together tighter, so again, you've got less infrastructure running that stuff up in the cloud. And of course, all the different reporting that you would expect to be able to get out of an engine like this. So that's the service in terms of how we enable it. I'll show that to you in just a moment. This is your traditional logo slide. Disney's probably one of the more interesting ones as they go from a fully baked on-prem environment, so full-blown private cloud, moving into the AWS. So they've been doing that for many years. Tons of workloads running up there today, and now a full containerized environments as well. Ticketmaster is a great example. If you go to our website and see what they're doing in terms of optimizing and the tagging and the automation. So really good use cases. And we'll say we've won a bunch of awards, and just this week we actually announced our AWS competency as a cloud optimization tool. So you can see that on the website, and we are on the AWS marketplace as well. In terms of the trial and how it works, so if you were to set this thing up, the connection is very easy. It simply just goes in, you plug in your information around your public or secret key information. You do that yourself, or your role information, your S3 buckets for billing. If you've got an on-prem environment for VMware, it just simply pulls this. It's all agentless. It's just using APIs. 15 minutes, your instance will be up and running. Takes a couple hours to churn through the analytics, depending on the size of your environment. Very quick to see what the analysis results and the opportunity are your expert insights from your densification advisor who's looking for certain opportunities for you, and of course, all the custom reporting. So that's it. We've got 30 seconds left. No time for questions here today. But if you'd like to come and see us at the booth, we're at booth 2420, just up the road here from Accenture. And come by and have a chat, and I'll be happy to talk a little more details about your specific requirements. Okay, so thanks very much for your time today.